Sorry, it isn't the end, because I actually forgot C. C's tough. C's tough to read it off the end of the page, so it makes you think, oh, I'm going to finish that question. You haven't. Estimate for the median time. So the median's halfway in all the values. So what I'm going to do is add these numbers together. There are two different methods here, but this is the one I prefer. So add your numbers together. So 20 plus your 30 plus your 45 plus your 60 plus your 48 gives you 203. So the median will be, add 1 and half it, it'll be 102nd number going along. So what we do is we add the frequencies up, add the first three first of all, until we get to that number. So we've got 20 plus 30 plus 45 gives us 95. So 95 numbers have been in here. So how many more do I need to add on then to get to my 102nd? Well, I take 95 off, so I've got 7. So I've got 7 more numbers to add into this area here. So it's 7 out of 60 numbers, and I'm timesing that by the class width, because that will tell me how far in to these numbers I need to go. So 7 divided by 60 times by 20 gives me 2.3 recurring. So I've got to go 2.3 into this. So an estimate for the median then for me would be 40, add my 2.3 recurring, so 42.3 recurring there. There is a method to use the graph, and if you want to see me about that you can do, but I prefer that method because it's I think a bit more accurate. Question 13, there are 4 banana smoothies and 3 apple smoothies in a box. Jenny takes one at random, writes down its flavour and puts it back in the box. She takes at random second smoothie from the box. So she puts it back, meaning that there will be no difference. If you take a banana, sometimes questions say don't replace, then that would change to 3 over 6. But because she puts them back, the probabilities here are exactly the same running through the question. So we've got those down, and then it says work out the probability that both smoothies are apple flavour. Well, apple flavour, probability of apple and apple is going along this route, so it's 3/7, and then it's times by another 3/7, which then gives you 9 over 49. And question 14. A farmer wants to estimate the number of rabbits on his farm. On a Monday, he catches 120 rabbits. He puts a tag on each rabbit. He then lets the rabbits run away. On a Tuesday, the farmer catches 70 rabbits. 15 of these rabbits have a tag on them. Work out an estimate for the number of rabbits on the farm. You must add any assumptions that you've made. Well, what you've got to do is that on the day, so the problem is from Monday to a Tuesday, the sample hasn't changed, so I've got to presume total number has stayed the same overnight. Now the easiest way I find doing this is to say if I've got 120 out of my sample, so I'm going to call that T, total sample, that proportion, I'd expect the same proportion on Tuesday, so I'd expect that then to be 15 out of 70. So if we do some manipulation here, I'm going to first of all work out 15 divided by 70. So that gives me an awkward little number, so instead of doing that I'm going to manipulate it first. So dividing by 70, shift it to the other side, becomes a times by 70. And I'm also going to times my T up to this side, so I get 15T. So 15T equals 8,400. So then we divide that by 15, which will then give me 560. You could do it slightly different to what I've done. As long as you're getting 560, proportionality is working. But you've got to write down your assumption.